Hi everyone, my name is Jake Smeester. I am the Creative Content Specialist for Amazon Sumerian, and today we are going to be covering physics in Amazon Sumerian. Let me switch this over here. Look at that. We will be covering physics, colliders, rigid bodies, and actions. Physics is a really important part of Amazon Sumerian, so how do you actually add in physics and gravity to take place within your scene? How does that work? There's several different components that are involved, and we can also add actions that interact with those components. And so that's what we're going to be looking at today. So let's get to it. All right. Let's see. Let me just move myself over a little bit. There we go. All right. We are here at the dashboard from Amazon Sumerian. I already started one, rigid body actions. That's what I started. I'm going to be rebuilding that one, but we'll start from scratch. We will go look at the default lighting scene. So let's open up that one, and we'll just call it physics. If I could type correctly, physics. All right, and as this loads, here we are. We are in a scene. An empty, well, almost empty scene. All right, so there is not much going on here, except for we have the default lights, which you should be somewhat familiar with if you've looked at Amazon Sumerian before. The default lights involve 3 different directional lights. There's the 1, 2, and 3. So they're highlighted in the scene or selected in the scene. Directional lights operate kind of like the sun. So they shine or emit light from a source that's infinitely far away. Even though it looks like they're in the middle of the scene, it really is just coming from way far away up in that direction. So that is what we have in the scene. We also have the skybox and sky sphere. And so that's what we see in the distance here as well. Something I forgot to do. Forgot to turn off notifications for other things. Okay, so we got that turned off. All right, so where do we start? Well, to add physics, the first thing we need is something to act as the ground. So we need something to act as if it is a solid surface pretending to be the ground or the floor of our scene. And so what we can do is create, or what I often use is a disk. So we're going to go ahead and create an entity up here above the canvas. So we'll select that. And we'll add a disk, which is one of the 3D primitives, as you can see right here. Okay. And that puts a disk in the middle of our scene. We are kind of zoomed out far. So again, you want to use the hotkeys to quickly zoom in. Press the F key, and that will take you and frame that disk right in the middle of your canvas. All right, as you notice, the disk is cutting up and down horizontally. And also, if you take your mouse and you move around, you'll notice that you can only see the disk from one side, which is fine for what we're doing, but we just got to make sure. If we let's flip the disk around, and I'll show you what you mean. If we do 90 degrees, the visible side is facing down. There it is. So if you want it to face up, or the visible side to face up, you make it negative 90 degrees. So there we are. All right, we don't want it to be one, just the size of 1, 1, 1. That's really just a meter in diameter. We want it to be a lot bigger, so I'm just going to go ahead and make it 1,000. If your uniform scale is clicked right here, as you make those changes, it'll change those values for each vector or axes. All right, so if I zoom out, the disk goes pretty far out there. If I do select the F key on the disk, it will frame the whole disk in the middle of my scene. The reason why it's cutting off here is based on the camera settings that I have on that camera. That's why it's not seeing the whole thing, but as I zoom in, there we go. All right. So we got a disk acting as the floor. I could rename it if I want to be floor or ground or something like that, but really no need at the moment. Let's see. So let's add a component. To make this act as solid ground, let's back up. Let's add something else. We're going to create an entity and add a box because I want to show you something. And that puts a box in our scene. it's slicing halfway through the disk, and so we want to just bring that up. We'll zoom out a little bit to something like that. Let's change the material or the color of this. So we'll select the material, and it's a light gray right now, so I will select it, and we'll make it something like blue. Great. And let's see, we also need to add 2 components to make this both a solid object and an object that reacts to gravity. So let's click Add Component, and we're going to add, let's first make it a rigid body. So let's add a rigid body to it. A rigid body will then treat it as if it is an object that responds to gravity. So when you press play, it will actually fall to the ground. So let's give that a shot. Press play, and it falls. Great. I'm going to zoom out, stop and zoom out and move up the box a little bit. Press play again. There we go. It falls down. And it's going to fall infinitely into the abyss below, in the bottom of our scene. It's just going to keep on falling because there is really no end to it. Okay, so that's it. But how do we get it to collide with the ground? Well, there's 2 issues here. First of all, Sumerian does not recognize the box as a solid object, something that can be collided with. It recognizes it as something that responds to gravity, but it doesn't recognize it as something that can collide or run into any other objects within our scene. So what we need to do is add a collider component to our box. And because the box is shaped like a box, go figure, the shape will just leave set as a box. So if we press play, what will happen? Same thing. Press play again. Just falls straight through. Why is that? That's because even though the box is set as a solid object that responds to gravity, the ground or this disk is not set to respond, or is not set as a solid object. So this box doesn't know that this disk is here because there's not a collider on the disk. So that means we got to put a collider on the disk as well. So we'll select disk, we'll add component, and we will select collider. However, the disk is not in the shape of a box, so we need to change the shape of the collider. So we're going to click this drop down, and we'll click infinite plane. So that means the collider will run infinitely on this plane that is set to be horizontal. All right, so let's press play, and what should happen is this box actually lands on the disk. There we go. All right. So now we have some physics actually acting in our scene. So this box is responding to gravity. It falls when we enter play mode, and it is treated as a solid object as well as the disk, and so it lands on the ground and responds in a manner you'd expect in a real world, with real world solid objects. Okay, so that's really the basics of physics in terms of the components you need to add to your objects or your entities. Okay, so if you remember that just because the box is set as a solid object that responds to gravity, meaning it has a collider and a rigid body, you need it to be able to run into something else. The ground has to be set as a solid object as well. However, do we want the ground to respond to gravity? Well, let's see what happens. Let's see, I have the disk selected. I'm going to click Add Component, and then I'm going to add a rigid body to the disk as well. Well, what happens? I'm going to press play. Notice that the disk is falling down as well. So it's just getting further and further away because it's falling as well. So that obviously is not really what we want to do. So that's why we don't want a rigid body on the disk. We want it to stay put. So we'll just click on the rigid body over here with the disk selected. We want to remove, click this gear wheel, and then click remove. All right. So those are some of the basics of physics. But we want to use the state machine as well to make some interactivity happen, or some actions to take place based on the rigid body of this box. Okay, so what we want to do is add a state machine to, I don't have the box selected. Select this box, and we will add a state machine to this box. All right, remember the state machine is the component that actually adds behaviors or interactivity is another word I like to use. Some behaviors, interactivity, so we can make something happen within our scene based on clicks, based on movement. So one action occurs or one event occurs, and then an action responds to that. So that's the way we actually make things happen within our scene. All right, so we have a state machine added, and then we're going to press the plus button to add a behavior. And we have our scene here. And I'm going to just do one thing. I want to make sure that I am streaming properly, as I should be. Just excuse me 1 second. I'm just making sure that this is working as expected. Great, it is. All right. I didn't have Twitch actually pulled up myself, so I want to make sure that I was streaming properly, and I am. Great. All right, so we only have two really entities in our scene, this disk and this box. That's good enough. In the last several broadcasts, we looked at a lot of different state machine actions. And if you're watching any of those broadcasts, you may have noticed I sort of skipped over some of the rigid body actions. That, or I explained them and then I moved on, and I didn't make a lot of sense. That's because I just didn't actually fully understand them at the time, and now I've really dived deep into them and understand much better how they actually function and how they work. That's why I wanted to have this separate one to either clarify something that I may have said that was incorrect, and also just have a very clear cut and simple and straightforward demonstration of how these actions work. Okay, so we're going to have two states in this behavior. The first state is going to be a click action. So we're going to rename it click, and then we're going to add action, and we'll search for click. So this is click or tap on entity. Click meaning it responds to a mouse click. Tap meaning it responds to a touch if you're using mobile. So I'll add that. Oh, I put it on the wrong one. You know what? That's okay. I'll just move it over here. And then this other state, I'll just name it action. Meaning we're going to be changing these action. Well, so we'll call it X action. So we don't, to let you know that we are changing that value. All right, so, and all we need to do is just add a transition. So what happens here is when I click on the box, an action on the box will also take place. And that's what we're going to be experimenting with. All right, so now with the X action state selected, I'm going to click add action and then type in rigid body. All right, if you notice, there are a few things going on here, or several different actions. This start microphone recording, that has, yeah, it's still there. That is not one we're going to be looking at. We're going to be looking at these other ones. So apply impulse on rigid body, set rigid body position, set rigid body angular velocity, set rigid body velocity, set rigid body rotation, apply force on a rigid body, apply torque on a rigid body. Those are the different ones we're going to look at. Some of them are very similar, and there's very slight differences involved with them. And so that's what we want to look at. All right, so the first thing we're going to add is, let's just start from the top of the list. Actually, no, we're going to apply force on rigid body, because this is sort of the basic one. Let's see here. Apply force on rigid body. Applying force to a rigid body, and in this case our box, which has a rigid body on it, that force is essentially going to be a constantly applied force to that entity. So once that action starts taking place, every frame is going to be added to the force value that we that we define here in this action or on this state. So let's try it. I'm going to be primarily using I'm going to be primarily using the z value, or adding force values to the z axis. So we'll just make it 30. And let's press play. And I see what happened here. I need to have click set as the initial state. So as soon as because the X action state was set as the initial state, that force was automatically applied to it as soon as I press play, which I don't want to happen. I want to be able to click on it, the box, and then have the force applied. Okay, there we go. Started rolling off. I'm going to kind of rotate it. Okay, so this blue gizmo or handle on the box represents the Z axis. The red represents the X, and the yellow, or the green, I'm sorry, represents the Y axis. And so because let's go back to this X action, because we applied a force value to the X axis, it's going to be the forces are going to be coming on this side of the box and be going in that direction forward, because that's along the X axis. So let's press play. Our box falls to the ground, as it always has been. And then we click on it, and you see how it keeps going. It goes off in the distance because every frame, a force value of 30 is being applied to that entity. So it just keeps going off into the distance till we can't see it anymore. Great. So that is the basics of an apply force on rigid body. However, there are some other values here, properties that we can add. Apply point. This is a little bit unique. So imagine that we have a invisible plane added to each side of our box. And so if I apply a force value of, or not force value, if I apply a force on the 30 Z value, that means that we are applying, if we put let's see, we can, I'm trying to do this with my hands right. If we apply force to that entity, and there's a plane, it's going to apply force to an invisible plane that extends beyond that entity. And so because the Z axis slices through the middle of the entity right here, the force is going to be added 30 units away from it, and so it's going to spin it around like this. So let's give it a shot. That's not a good example. I'm actually going to add it to the x-axis. This will make it a little bit easier to see. Okay. You see how it spins. That's because the force value is being added at a point distance away from the entity. Even though the entity actually isn't in that space, the invisible plane attached to that entity does reach, and that's where the force is being applied. Okay, so let's add 30 to the y-axis. And click on it. There we go. And then it bounces off into the distance because it was spinning. And it kept bouncing off of the ground, and because of that force was constantly applied, then it really just kicked into effect, and it just got booted way, way off into the distance. So that's what apply force on rigid body. The apply point is what is interesting, is because then you can start actually adding, I did not mean to keep that at 30 on the z-axis. The apply force on rigid body action is unique in the fact that you can add that kind of the apply point. And so it's not just necessarily smacking the force isn't being applied just directly on the entity itself. It can be applied to a point very distant from the center of that entity, and you can make it spin or rotate kind of however you want. All right, so that is apply force on rigid body. The apply point, again, is the property that makes it a little bit interesting and slightly more difficult to understand and explain. But the apply force on rigid body is the force values itself isn't too difficult. However, let's just try something else. Let's try 30 on the y-axis. Let's press play. And what should happen here is that it's just going to be, force is going to be applied downward, or is actually applied up. Yeah, so it's applied up. So because it's coming from positive, that means that the force is coming from underneath the entity, and it hits it at the bottom and kicks it up into the air. If I make this negative 30, we'll press stop, press play. Force is going to be coming down on top of the entity, and it really should just bounce. It wasn't really enough to see. Let's just try it again. Yeah, can't really see it, but it didn't move because it's being squished essentially in between the ground or the plane below it and the force on top of it. All right, so apply force on rigid body. That's it's a very basic action, and also you can select the space drop down, either world or local. That refers to the apply point values. And so are those values in reference to the entire world or just the entity itself? All right, enough of that one. I'm going to remove that one and then add another action. My rigid body search is still up here. So let's apply force on rigid body. We did that. Let's now go up to the top and apply impulse on rigid body. All right, impulse is a little bit different. Let's just add 30 again to the Z. Press play. Let's just see what happens when I apply it to this entity. There you go. See, if you notice though, it stops. Stops way over here. That's because a force value was only applied once, whereas the apply force on rigid body action, that is constantly applying that force every frame to that entity. This one, this action, apply impulse, is basically just like kicking the entity. So you apply one quick punch to that entity and it moves in whatever direction. Same thing can happen if we go into on the y-axis, or press play. Click the box and it should just be punted up in the air and it should fall back down. I don't know when. There it goes. There we go. And it bounces off the ground a little bit. Okay, that's because a force value was only applied one time instead of on every single frame. So whereas the box with the other action just kept moving off into the distance, that's not what's going to happen here. It's only going to be kicked once or booted once. So let's add 30, 30, and 30. So essentially we're adding a force value from this direction, and from underneath. So it should kind of go at an angle. Let's see how it works. Oops, I got to play it again. All right, so there we go. So it gets punted off in that direction. And because the force value was added on every single side or dimension of that entity, that's why it was spinning. But again, you still can apply the force values here as well. Like you could, just like with the other one, the other action, you can apply the force to a point that extends beyond the spatial location of the entity itself. All right, so let's press stop. And so impulse, it's basically a one-time force value. And then let's add action. Let's set rigid body velocity. And then you notice there's no apply point here. It just gives us these options. So I'm going to do 30 again. There we go. And it applies that force value again on the Z value or the Z axis. And it looks really similar to the last one. I'm actually going to go ahead and add again that apply impulse on rigid body. So I have both of them, but I'm only going to use one at a time. So let's try this again. We're looking at the difference between the set rigid body velocity action and the apply impulse on rigid body action. So currently we're looking at the set velocity. Okay, so again, it looks like it's punted or just kind of booted. Let's set that back to 0. And then let's set the apply impulse on rigid body to 30 and see if we can notice any difference. So the difference is this. The apply impulse, because it's kicked, it's going to start from a point, it's going to start from a value of 0. So it's going to have force applied to it, and so it's going to accelerate from 0 to whatever velocity that it's set to, or that it would reach in a simulation. But it does actually accelerate from 0 to that velocity, from 0 to, again, x velocity. However, the set rigid body velocity is automatically applying that velocity on the very first frame. So it looks really similar, but the difference is that the impulse actually it accelerates from 0 to some value, whereas set rigid body velocity starts off immediately at that set value. And so it does not actually accelerate. You would have to apply a lot of different values and higher values. So let's even try 100 and add this one 0. Let's look at the difference, see if there's much of a difference. It might be, again, hard to tell. And then let's go back. Let's add 100 to the apply impulse. Yeah, it's hard to tell the difference. It looks really similar, but there is a technical difference in that. One is accelerating and one is immediately starting at that value. So those are the differences between those two. Whereas the force value isn't just like a one-time kick with a velocity value or an impulse. A force value is constantly being applied to it, and so it will just keep moving off into the distance. All right, so those are the three main ones. I'm going to go ahead and add on the force so you can just see it. So on my screen here, I am in the way, actually. So I'm going to slide myself over. There we go. And okay. There we go. So now you can see a little better. So we have three different action types, essentially. Set rigid body, the velocity, impulse, and force. Velocity is applying a velocity value immediately, but only on one frame. Impulse is essentially adding an impulse, but an impulse using a force value, but accelerates from 0 to x value. Whereas apply force is constantly applying force to this entity on every single frame. So that's the differences between the three main types of physics actions for rigid bodies. So I'm going to start deleting these here. And I'm going to click Add Action, and let's try some other ones. All right, set rigid body position. Actually, no, let's not go to that one. Let's set rigid body angular velocity. So again, this is going to be similar, except it's going to rotate it. So we'll try 30 again on the z-axis. There we go. Try it again. I think I need to go this way. There it is. So what it is doing is adding an angular velocity on around the z-axis. So you notice, so the z-axis is going this way through the box, and it is spinning around that axis. And so it's like almost as if there's like an axle going right through it, and you're spinning the box around that one. So let's try it again. We'll zoom in a bit. Let's try it again. I want to get one perspective here, and then there we go. It's a small punch, and it's rotating around that. So let's try doing 100. See what happens. See, it's really spinning around a lot more with a higher value, of course. Okay, moving on, we'll try 100 around the z-axis. The z-axis is kind of coming this way through it, and so it should spin this way. Or wait, nope, looking at my, there we go, this way. My camera is making me backwards. So it should spin this way around the z-axis cutting through it. All right, so let's see it. Oh, the opposite. It is spinning around it, but it's rotating counterclockwise. Counterclockwise. So zoom out a little bit. Okay. Now if we do the same thing, but on the y-axis, let's see how that responds. Yep. So it's spinning kind of like a top because the y-axis goes down through the middle, and so it's spinning around it like it's a pole. All right. So that is set angular velocity. And then let's look at, let's see, let's apply torque on a rigid body. All right, this is going to be really similar. And let's test it out. Let's do 30 on the z-axis. Okay, what happened here? All right, I see it in the distance. Okay, so the difference here is that, again, with the last action, when it's set angular, or set, what was it again? I can't remember. Set rigid body angular velocity. That one, again, is only applying a force one time. And so that's why it spins and then it stops and lets gravity, so to speak, come into play. Whereas the applied torque is going to constantly apply a torque force value onto the entity. So that's why it just keeps going off of there into the distance. But it's also going to be rotating around the different axes in which unless you define the force value. And there it goes off into the distance. All right, so that is applied torque. Similar to the velocity, but it's doing it continuously. All right, we're going to remove that one. Just got a couple more here. This might be a slightly shorter broadcast. Set rigid body position. This should probably more accurately be described as set rigid body translation because it's going to actually change the position of it. All right, so let's look at our box. Where are we? What's the transform value? It's almost, right now it's at 5. We'll just say 5 value. It's the very, very center of our scene except for the Y. But when we press play, it falls back down. So it's really, the value is almost 0, 0, 0. The translation value of the box now that we've played it and it falls to the ground. And so let's do some things here. Let's go 5. No, not 50. 5, 5. What that'll do is it will then it'll move this entity instantly in one frame to the position of 5, 5, 5. There it goes. But it falls to the ground because, of course, the rigid body is applied to it. So what happens if we do, let's do 10, 10, 10. There it goes. All right, so it automatically moves it to that new translation value. It says position, but I, for one, do use position and translation synonymously. Okay, let's see. I think there is about one more. Set rigid body rotation. All right. Okay, this is really going to be similar as to the set rigid body rotate or position, But rotation is just going to alter the rotation of it. So let's do something like 20, 30, and we can leave it at 0. So right now you notice that there's no rotation added to the box. It's just it's straightforward as it comes into our scene. But once I click on it, what happens? Try it again. What happens is it tries to move it to that new rotation, but because force is added to it, or I'm sorry, because a rigid body is added to it, it can't actually get there. It essentially kind of runs into the ground and it bounces back to almost where it was before. So let's add in one more action. And we'll use the set rigid body position as well. And we'll do 5. Keep doing that. 5, 5, 5. All right, so what this will do is that it will set the rotation of it, so it'll actually move, it'll rotate the entity, and it'll actually move it up into the air in another place. So you'll actually be able to see it rotated because it'll be up in the air. The rigid body, the ground won't be blocking it from being rotated. There you go. There we go. And it falls to the ground, and then it responds to gravity in physics as it would, where it kind of tumbles around and then settles on the ground. Let's do that one more time. Great. Cool. One last thing I wanted to show. Let's do apply impulse and do 30. There's one other setting I want you just to experiment with. Let's go to rigid body. So we're on the box and we open up the rigid body and I'm sorry, not rigid body, collider. The friction is set to 0.3. Go ahead and set that to 0. And let's go back to our behavior. And we did add the apply impulse. So right now there's friction applied to both the collider on the box and a collider on the ground. So friction meaning it will eventually come to a stop because there's friction applied between these two objects. But with no friction applied, it will really start acting as an object would if it was just sliding around on ice. So see, instead of like running against the ground and then tumbling, it's essentially being hit from the side, and it just goes forever because nothing is slowing it down. There's no friction to stop the box from moving. And so that's what messing with the friction value can do. You can do the same also with the disk. I'm gonna just get out of here. But I believe if you turned the friction down on just one of the entities, it should affect. Let's see. It's just it should keep on going for pretty far. Because I believe at no point will friction ever be added. So it's almost like acting like an object in space where nothing's going to slow it down. It's just going to keep going. So even though there is gravity applied to it, there's no friction. So it'll just slide away into nowhere. There we go. Now it's gone. All right. Let's go back to the box. Let's just make sure that I'm not missing anything. Going back to this behavior, we'll press stop. Oops, toggle on the state machine, select our X action, remove this, add action. Let's go back to our list. So let's see, apply impulse on rigid body. That's a one-time kick to the entity. So it adds a one-time on one frame, a force value, and then it will slow down after that. Set rigid body position. We'll just literally take and move in one frame from one position to another within our scene. And one thing to notice is that you can do, let's go look at tween real quick. Oh, no, that's not what I wanted. Tween position. Let's see, tween move. I did not mean to do tween light. All right, so this tween move, it's similar to the set position, set rigid body position, except what it will do is it will really be more of an animation. So instead of it moving it from one position to another position in a single frame, it'll move it animated, and you can set the time amount, which is right here, which is 10 seconds, I believe. 1,000 milliseconds. That might just be 1 second. I can't remember. Let's press play. Interesting. I think the reason why this is not working is because there is a rigid body set on, so it's fighting against moving the entity as well as trying to stay consistent with falling to the ground. So, so there are some differences. So set position, let's go back to our list. So we search for rigid body. So set rigid body position will move it instantaneously within one frame, whereas tween move will move it gradually from one position to another, and it will animate and show you the difference between those two positions. It'll let you you'll see it moving over a course of time. Anyway, so back to this. Set rigid body angular velocity. That will spin an object around one of the axes or multiple axes, but it's a one-time force value added, so it will slow down eventually. Set rigid body velocity, same thing. It's just adding a force value from one angle or from one side, but it's a one-time force value. Set rigid body rotation, similar to set body position, will rotate the entity. But again, if you have a rigid body on it, or it is sitting in a certain spot, it will fight against that. It will fight against it's running into a collider, I guess is the best way to say it. It will fight against a collider. Apply force on rigid body is continually force added to the entity, so it'll keep moving off into infinity. And then apply torque is a similar, but it's adding a rotational or a spin torque onto the entity and doing it continuously. And so those are the different types of actions we have, physics-related actions we have for Amazon Sumerian. Oh, somebody asked me a question. Is there generally some way to know if an action is applied every frame or just once, other than memorizing? There currently is not. That's a good question. There's currently not. That's why I wanted to actually explain these different ones. And that might be something we could be interested in looking at as like a checkbox, as that'd be probably pretty useful. So to answer your question, no, not currently. But there's only actually 3 different action types. And so it's the force and the torque are the 2 that are added continuously. Velocity and impulse are not. I hope that answers your question. Chris Chan, 1712. Any other questions I can answer? Thanks for joining, Chris Chan. I can hang out for a bit. I hope you all are enjoying the new lighting I have in my studio here. Some of our creatives said, your lighting needs to be improved. And so they came in here and helped me do it. And so hopefully I don't look as washed out as I did before. Okay, great. Yeah, physics, really, really important part of Sumerian to make real-world simulations and gravitational simulations, collider simulations, so you can actually treat objects as physical objects that can collide with one another. Lots of different things. And again, there can be subtle differences like velocity versus impulse. They're subtle, but they do exist and they are there. Again, thanks for joining us. Thanks for joining me. If you have any questions, let's go back to this, and we'll do that. That's not the one I wanted. This is the one I wanted. There we go. Again, creative content specialist for Amazon Sumerian. Jake Smeester is my Twitter handle, so you can always find me there. Thanks for joining us. Let me know if I can answer any other questions. Would love the contributions for you guys on Twitter and also on Slack, which is slack.sumerian.world. That's right. Slack.sumerian.world is where you can find us. We have a large and growing community of people that are using Sumerian. So, yeah, let us know how we can help. Thank you guys so much.